Hello, today I'm going to have a look at the binomial distribution and in particular how the new calculator works for the A-level because we're no longer concentrating on using tables. So a quick reminder of the binomial distribution. The binomial distribution is where you're trying something repeatedly and seeing how many successes or failures you get. So for example, I might be spinning a spinner and I might know the probability of success. So success in this case is landing on orange. So in this case the probability is a fifth. And I might know how many attempts I'm going to have. So I might have 10 attempts and I might be saying how many times is it going to land on orange, and landing on orange would be a success. So the conditions for using the binomial distribution are that it's a discrete distribution. That means that I can't have 2 1/3 successes, I've got to have a whole number of successes. And the conditions are that we know the number of trials at the start, it's a fixed number of trials. We're not just carrying on until we get a success, we know where we're aiming for. For every trial there is 2 possible outcomes, success or failure, and the results for trial must be independent. So if it's something like shooting at a goal, then it might be the case that if I shoot more and more of the goal, if I score a goal once, I might be more likely to score a goal the next time. That wouldn't be a binomial distribution because it's not independent. So it must be independent. It must be the case that the next result is unaffected by any of the previous results, and the probability must remain constant. So I can't have one spinner where the probability is a fifth, and then another spinner where the probability is a 12th. That wouldn't be a binomial distribution. We must have the same probabilities all the way through. So for my spinner, I can record my probabilities. I'm going to spin my spinner 6 times, and it's how many successes, how many times does it land on orange out of those 6 times. So I'm going to go 1, and that's a failure, 2, failure, 3, failure, 4, failure, 5, failure, and 6. And that's a failure. So I had 6 spins, I got no successes. The probability of that happening is 0.2621. Now I've used GeoGebra to work this out, but we can work it out using our calculators. A quick reminder of how we're going to state this distribution. So I'm going to say x is distributed using a binomial distribution. The first number is the number of trials, so I've tried spinning the spinner 6 times. The second number is the probability. N is 6, P is 0.2. If I represent these probabilities, so these are the probabilities for each of my values. If I draw that as a bar chart or a histogram, I end up with this bar chart beneath. And you can see that the most common number of successes I'm going to get is 1 success. And then 0 successes and 2 successes are quite close after that, and by the time I get down to 6 successes, there's almost no chance of that happening. It's very unlikely I'm going to spin my spinner 6 times and get every spin to land on orange. Now, how do we get this table in the first place? So there's a formula for the probabilities, and our formula, which you should know, is the probability of getting a particular value is equal to n choose x times by the probability of success and how many successes we want times by the probability of failure to the power how many failures we want. Now this is quite a long formula and our calculator can do it for us, but you should know the formula because on some questions they'll use algebra or they will try and stop you from being able to do it on your calculator. So don't not learn the formula because we've got the calculator. But let's have a look at how we can get these values from our calculator. So here I've got a ClassWiz calculator. I'm using an emulator from Casio. Now we are looking for the probability of getting numbers. We're looking for the probability with an equal sign. So if we're looking for a probability with an equal sign, we're going to start by going to menu, and that will give us a few different options. From menu we're going to pick our distribution. So either we can use our buttons to scroll to where we want to go, or each option has a letter or a number associated to it. Our distribution option has 7, so we could also get there just by pressing 7. Now because we're looking for equals to, we're going to use PD. So that is our probability distribution. So I'm going to go for binomial PD because we're doing binomial and we're looking for an equals. And then we're going to go for variable. So I'm after the probability of getting a 2. That is this highlighted probability here. So I'm going to enter the details of my function. So x is how many successes I'm interested in getting. So I'm interested in getting 2 successes. N is the number of attempts I'm going to have. So I'm going to spin my spinner 6 times. And P is the probability of getting a success. Now you can enter numbers as a fraction. So you can just use the fraction button and I could say the probability is 1/5. Or I can enter it as a decimal. And once we've filled out all the information, we press equals and our calculator will give us the value and we can see that it's 0.24576. So this is giving me the probability of getting a 2. To change the value that I'm looking for, I can just press AC. That'll take me back to the options and then I can find the probability of getting a 4. And then, again, that just matches up to my table, 0.0154. Now, it might be the case that I want to find the probability of getting up to 2 successes. So I might be looking for 0 oranges, 1 orange, or 2 oranges out of my 6 spins. In that case, what I want to do is I want to find all the probabilities from 0, 1, or 2 successes. And the question might say, find the probability that x is less than or equal to 2. Now, I could find the entire list of probabilities and add them up, but that's a lot of work. Fortunately, our calculator lets us do that. So on my calculator, this time we're going to go to our menu and our distribution option, so menu and 7 again. But this time I'm going to select Binomial CD and I'm going to have to scroll down, so I'm going to have to press the down arrow on the calculator to get that. When I select that option, I again get list or variable. I'm going to go into variable and I'll get some data to fill out. So I'm going to say x is the number of successes. You can see it's got the information from our binomial PD, it's just carried it across. So I'm saying that I want 2 successes, n is 6, p is still 0.2, and that will tell me that the probability, when I add up all these probabilities, is 0.901. Let's just double check that by adding up our probability. So if I go to the normal mode on my calculator, I can type in my probabilities and just add them up and see if that matches. And you can see that we get our 0.9011. What you'll notice when we're in our binomial CD mode is that we don't get an option for how our sign goes. Our sign, to use our calculator, must be a less than or equals sign. So if I wanted to, for example, know the probability that x is less than 4, now because it's a discrete distribution, x can't be 3.5 or x can't be 3.1. Now I know that the probability that x is less than 4 is the same as the probability that x is less than or equal to 3. On my bar chart, if I'm saying x is less than 4, so x is 4 this way, then I'm saying x is equal to 3 or less than 3. So that is why I can just change it round to this less than or equal symbol, and now I can use my calculator as I did before. So to answer this question, I would go into my binomial CD, I'd say this time I want 3 because that's how it is with my less than or equal symbol, n is still 6, and p is 0.2. And this tells me that my probability is 0.98304. So if I've got a less than or equal to symbol, that's fine. If I had x is less than 5, I'd need to change that to x is less than or equal to 4. If the number of successes we're looking for is greater than 5, that means it could be 6, 7, 8 or 9. So that is going to be 1 take away the probability that x is less than or equal to 5. So greater than 5, if I had a number line 2, 3, 4, 5, 6, 7, 8, greater than 5 is these numbers, so I know that my probabilities add up to 1, so all of this adds up to 1, and I want to get rid of less than or equal to 5. This gets it into the form where I can use my calculator. And finally, greater than or equal to 5, I'd be doing 1 take away the probability that x is less than or equal to 4. Now, I would often draw out a number line to help me with this. So if I had a question which was find the probability that x is greater than or equal to 5, I may well just do a few numbers around 5, so 5, 4, 6, a couple of numbers around 5. I want greater than or equal to 5, so I want this, and then I can see very quickly I need to take away less than or equal to 4. Let's have a look at how this applies to an exam question. So here's an exam question taken from the MEI paper. We've got a doctor's surgery, and the records show that 20% of the patients who make appointments fail to turn up for their appointment. During an afternoon surgery, the doctor has time to see 16 patients, so we've made 16 appointments. Find the probability that all 16 of our patients turn up. So the first thing to do is state that I realise this is a binomial distribution. N is 16, the number of people. The probability is 20%, so that's going to be 0.2. And question 1, find the probability that all 16 patients turn up. If I've got my probabilities being 0.2, that means that a success is somebody not turning up. So in question 1, we're looking for the probability that there are no people who fail to turn up. So I can use my formula for this, or I can grab my calculator. I'm going to go to my distribution, and I'm going to say that I'm looking for an equals. So equals, we said, was binomial PD. And then I fill in my information. So I'm interested in 0 people failing to turn up. Out of the 16 people who are there, the probability of them failing to turn up is 0.2. The probability of this happening is 0.0281. Find the probability that more than 3 patients don't turn up. So in this case, I'm saying what is the probability that the number of patients who don't turn up is greater than 3. So I'm going to think about my numbers around 3. And if I'm saying greater than 3, that is 1 minus the probability that x is 3 or less. So I'm going to do 1 minus, and then because I'm doing multiple probabilities, because I've got an inequality sign on my distribution, I'm going to go to Binomial CD. And this time my x value is going to be 3, so I get 0.598. Now, the nice thing about using a calculator is if I go to my normal mode, I can now use the last number as my answer, so I can use my exact value to get my probability 0.402.
Hello guys at Amos Maths. It's student Ran Hector here. We're talking about greater than and less than signs. So what you got to know is that greater than and more than. So this one means less than 5, and this one means more than 5. You've got to remember that the crocodile eats the biggest number.